Welcome to our webcast, How to Improve Your Manufacturing Process Using Additive Manufacturing. My name is Julie Rize, and I'm the Vice President of Marketing and Channel Relations at Rize, and I'll be your host for today's webcast. McKinsey Global Institute estimates that the total sales of direct manufactured goods and tooling will reach $800 billion in sales by 2025, and of that, $250 billion in sales will come from 3D printed products, mostly consumer goods, tooling, and direct manufactured products that will be 3D printed. If you run your company's manufacturing operation, you're well aware that you're tasked with producing better products faster while cutting costs, increasing production uptime, finding a way to efficiently meet customer demands for customized products, and support your organization's innovation initiatives that impact all your organization's processes and products. It feels like a daunting task, and maybe even mutually exclusive in some cases. With so much manufacturing revenue predicted for products manufactured with 3D printers, how can you harness 3D printing tech to meet these goals and improve your manufacturing process? In this webcast, we'll talk about 3 key ways you can use additive manufacturing to improve manufacturing at your organization. Augment your additive manufacturing lab systems, 3D print replacement and custom tooling, and 3D print short-run, custom, end-use parts outside the lab. First, augmenting your additive manufacturing labs systems. You can augment the systems in your additive manufacturing lab with industrial 3D printers placed in your engineering and design offices to speed your R&D process and cut costs, right on the production floor to keep the line running and running efficiently, and in the field so you can accommodate your company's innovation initiatives, not the other way around. Putting a 3D printer in the office, on the production floor, and in the field offloads overburdened lab managers. Many lab managers welcome the idea of putting printers in their engineering offices so they can print their one-offs, leaving the big jobs for the lab. Gary Rabinovitz, additive manufacturing lab manager at Reebok, said a nearly zero post-processing and environmentally friendly 3D printer would enable their designers to 3D print themselves and reduce some of the workload from the lab. And John DiPiano of Boston Engineering said it's so convenient. Whenever we need to print a part, it's right here. We just print it and we have it. We don't have to wait in the queue for the lab. This helps reduce bottlenecks created by overburdened labs, speeding part delivery, design iterations, and time to market, all while cutting costs. According to Boston Engineering, not only was the purchase price of the Rize 3D printer a fraction of the cost of the FDM system, the Rize material costs are less than half the cost of FDM, and there are no labor, facilities, disposal, and material costs associated with post-processing that need to be incurred with the lab's FDM printer. A global consumer packaged goods manufacturer reported that augmenting their Fortis lab system with their Rize office system yielded the following results: 20% faster in days per idea per engineer than Fortis, their lab machine, more iterations, 25% more concepts per engineer than Fortis, or an additional iteration, which means better designs in the same time frame. They estimate that part delays due to post-processing amount to 48 days per engineer per year. Times 100 engineers, that's 4,800 days in total part delays per year. They estimate that those delays are costing them millions of dollars annually. Boston Engineering reports that augmenting their lab system by placing a Rize 1 3D printer in their engineering office sped part turnaround time by 50%, and it also cut costs by the same amount. Next, we'll discuss how 3D printing replacement and custom tooling can improve your manufacturing process. You can place an industrial-grade 3D printer right on the production floor to print replacement parts when and where you need them, to keep the line running, to design and build custom parts in hours instead of days or even weeks in order to significantly speed the process. to change physical inventory into digital inventory. All of this significantly speeds the production process while cutting costs. Transforming physical to digital inventory eliminates inventory space, prevents parts from becoming obsolete, and ensures you don't run out of inventory. The final way we'll cover how additive manufacturing can help improve your manufacturing process is to 3D print short-run, custom end-use parts outside the lab, in the field, whenever and wherever they're needed. I'm talking about placing an industrial-class 3D printer right in your tool shop, auto mechanic shop, or doctor's office to manufacture one-offs of custom products, such as replacement parts, aftermarket and custom auto parts, custom medical and production tooling, dental devices, and surgical guides. As we've seen earlier in this webcast, breaking the chains at the additive manufacturing lab and placing the manufacturing where and when it's needed results in enormous efficiency improvements in time and cost, and enables you to offer new, customized products and services that can't be produced in any other way. Within the next few years, you'll even be able to 3D print products like hearing aids with both hard and rubbery surfaces for maximum performance and comfort, antenna, smart sensors, microchip heat sinks, actuators, and circuit boards, and it will be possible to use additive manufacturing to produce products with flame retardant, conductive, and static dissipative materials. But what's needed in additive manufacturing capabilities to enable manufacturers to implement these three process improvements? What's needed? Products manufactured using 3D printers will need to have the same material properties like strength, surface finish, HDT, etc. as injection molded parts. They'll need to be in the same full color that you'd expect from parts manufactured using traditional means. If you're going to put a printer in your office or on the production floor, in the field, or in your medical office, the process needs to be clean and safe without harmful outgassing, and to produce many products, the materials must also be safe. In addition, the system must be small and light enough to be placed in any office or field environment, yet have a large enough build volume to print most parts needed. Since you're using the printer in part to gain cost efficiencies for your low-volume manufacturing process, it must be affordable to purchase and, more importantly, to operate. And finally, since the printer is going to be operated by mechanical and manufacturing engineers, mechanics, soldiers, doctors, and people who aren't experienced users, it must be as easy to use as your typical document printer. You just want to be able to send your file to the printer, press print, and have your usable part or completed product a few hours later. But the reality is that today's printers can't meet all of those requirements. At one end of the spectrum, you've got 3D printing tech that serves prototyping and tooling applications, and those professional systems must or should be located in labs. Or you have the hobby printers that simply don't meet the needs of industrial and commercial applications for a variety of reasons. At the other end of the spectrum in manufacturing, we have the metal 3D printers, and we also have the likes of HP and Carbon that are forging a path legitimizing 3D printing for manufacturing. But all of these systems must remain in the lab. They can't break out into the manufacturing environment, and they require you to make other sacrifices in complexity, time, cost, and even material properties. There's a big gap between prototyping and manufacturing. These technologies can't address the enormous market for functional prototypes and custom one-offs of production parts on demand in an office, next to the assembly line, in the mechanic shop, you name it. Rize is changing how products are designed and manufactured. We provide the only additive manufacturing tech that enables manufacturers and other commercial users to speed their R&D and production processes up to 100%. And save millions of dollars by producing injection molded quality parts on demand virtually anywhere, quickly, easily, cleanly, safely, and affordably. Here's how APD works. It involves a simultaneous extrusion of our own compound of medical and engineering grade thermoplastic and jetting of special inks. The thermoplastic is extruded first, forming the support. Release ink is jetted between the support and the first layer of the part. Thermoplastic is extruded, forming the part layers. Special inks are then jetted between the layers of the thermoplastic to change the material properties voxel by voxel. So, what does this process provide that differentiates us from existing technologies? Well, as I mentioned earlier, the holy grail of the 3D printing industry is to produce injection molded quality parts quickly and affordably. But today's 3D printers have complex and tedious pre-processing that requires additional software. Post-processing is slow, very expensive, messy, and unsafe. Other technologies have limited material properties. They don't have the suitable strength versus manufactured products. Access to industrial 3D printers is limited to labs. This causes delays and bottlenecks, and the process must accommodate lab limitations. They have limited or no color. They have unsafe and messy materials and processes. Those processes cost companies millions of dollars annually, and it limits the adoption of the technology, and they can't enable new applications and markets. Rize, on the other hand, tackles this. We offer effortless auto pre-processing with no extra software required. We have virtually zero post-processing, which means 50 to 100% faster time to usable part. Our parts are 2 times stronger than the competition, and we offer variable material properties and injection molded quality. We have on-demand access in offices, remote locations, and our printer will accommodate your company's innovative processes. We offer full-color thermoplastic. We have safe, recyclable, and clean materials and process. And our technology is a fraction of the cost to purchase and operate. This results in time efficiencies that saves companies millions of dollars a year. All of this expands the adoption of the technology and enables applications and markets that are not possible with any other 3D printing technology. Our simultaneous extrusion jetting APD technology enables us to 3D print replacement parts in the field, custom tooling, and so forth. We can do this today. Looking ahead in the not-too-distant future, we'll be able to print the kinds of products we talked about earlier: industrial brackets with composite materials, functional fillers, microchip heatsink with defined microstructure materials, multi-layer batteries with smart sensors, hearing aids with variable hardness, even flame retardant materials, conductive materials, and more. So let's return to our original checklist of improvements you need to make to your manufacturing process and how using Rize additive manufacturing technology to augment your additive manufacturing lab, produce custom and replacement tooling, fixtures, and jigs on the production floor, and build one-offs of custom end-use products in shops and doctors' offices meets those needs. You need to speed your production process. Using Rize technology to build injection molded quality parts on demand outside the lab can speed your process by 100%. You need to cut costs. Using Rize can save you millions of dollars per year in labor, facilities, materials, time to market, and other significant expenses. You need to reduce part errors, and since Rize increases the number of iterations each engineer can do per design, the accuracy of the part improves. Plus, you can enhance the accuracy and efficiency of your production line by printing custom tools on the fly. Customers also demand increasing customization, and it's a way for you to differentiate from your competitors, but it's difficult to customize efficiently. Rize cost and time efficiently enables you to produce one-offs of customized injection molded quality and use parts. More and more companies have VPs of innovation or chief innovation officers who are charged with turning processes and products on their heads in an effort to differentiate themselves and make the kinds of improvements we've discussed. While lab machines restrict innovation and require a company to work around its limitations, Rize accommodates your needs. You can run it virtually anywhere by anyone in the company at any time. Finally, please allow me to tell you a bit about who we are. We're a 3D printer manufacturer just outside of Boston. Rize was founded by and has a team of 3D printing pioneers, mostly from Z Corp, with more than 20 3D patents to our name. Our APT tech is patented in the US, Japan, China, and Korea, with patents pending in Europe, and we're venture-backed. Thank you for attending our webcast today. For more information, please visit us at www.rize3d.com.